Part B, cost of production. Costs in the short run versus costs in the long run. Okay, so for many firms, the division of total costs between fixed costs and variable costs depends on the time horizon that they're thinking about. So are they thinking about a short time horizon, or are they thinking about a long time horizon? Okay, so in the short time horizon, some costs can be considered as fixed, whereas in the long time horizon, all of the costs start to vary. So what was a fixed cost in the short run varies over the long run. Because many of the costs are fixed in the short run, but variable in the long run, a firm's long run cost curves differ from its short run cost curves. The principle of diminishing returns. This principle has an important influence on a firm or a company's marginal product curve. The marginal product of labor is how much does the output change from the addition of one extra unit of labor. So in other words, if a company adds one more unit of labor, how much will that increase their output? What the principle of diminishing returns tells us is that there's a tendency for the extra output that is achieved by an increase in a unit of an input to decrease. So in other words, you add an extra input. The first unit, you'll get a significant improvement in the output. The next unit of input you put in, you will get slightly less than before. So in other words, the output has increased at a decreasing rate. In other words, it's still improving, you're still having an increasing output, but not as much output as for the first unit of input. Okay. Now the next unit of input, the output would still increase, but again at a smaller rate. Okay, so this is called the principle of diminishing returns. Okay, diminishing means getting less. So the return you get for each unit of input becomes less for each additional unit put in. Okay, so you put in one unit, you get a lot of return at the output. The next unit, you get a little bit less. The next unit, you get a little bit less. Okay, now keeping this principle in mind, what do you think a firm's total product curve would look like? So the graph below shows us the shape of the total product curve when this principle of diminishing returns is in play. Okay, so the shape that we see is that for each additional person working, if you hold all of the other inputs constant, then for each additional worker you get an improvement, but the size of that improvement becomes less for each additional worker that's added. Okay, so an example of this, you might think about when you're watching them preparing your food in the cafe. So the people working at the shawarma to prepare a shawarma, they have a fixed work area. Okay, so one person working there can work very, very efficiently and has a certain rate of output of shawarmas, right? Let's say the orders coming in exceed what that one person can output. You might notice somebody come along to help, right? But when you add the extra person at the one workstation, it isn't doubling the rate of production of the shawarmas. And that can be because of overcrowding, for example, in a fixed production facility. So this sort of principle applies to many, many companies, and it's called the principle of diminishing returns. So let's look at a slightly more complex product curve. Okay, so in this graph here, you can see units of labor on the x-axis and jackets produced, so it's like a clothing factory, and each of these is per day on the y-axis. Okay, and what you'll see is that the principle of diminishing marginal returns isn't uniformly applicable to every part of this product curve. Okay, what we see in the initial stages of this particular factory is that for each additional person joining, we actually have an increase in productivity, an increase in the amount of output achieved for each additional worker. Okay, and this can be because of advantages due to specialization, for example. So you can get several different workers to work along an assembly line and get the production done more efficiently. Okay, so that's what we're getting in the initial part of this curve. So we describe that as increasing marginal returns. So for each additional worker, the output per worker, the number of jackets per worker, is actually going up. Yeah. So the gap on the y-axis between C and D is wider than the gap on the y-axis between B and C. And B and C is wider than between A and B. So we're getting an overall increase in efficiency for each additional worker up to 3 workers. Okay. Now, beyond 3 workers, each additional worker is producing additional output, but the change in that additional output is less and less for each additional worker. So we get this increase in jackets per day between D and E, and we get a smaller increase in jackets per day between E and F. Okay, so when we add each additional worker, we do increase our output, but at a smaller increase in output for each additional worker. So this is the section between D and H that we describe as diminishing marginal returns. Another thing is possible. Beyond H, it could be that the factory is getting truly overcrowded now, and adding an extra worker up to 8 actually decreases the output of jackets per day. Okay, so we could describe that as a negative marginal returns. For each additional worker, we're actually having a reduction in the output per day. Fixed versus variable costs. So for any particular company, they can divide their costs into 2 categories, either fixed costs, and fixed costs would be costs that do not depend on how many units the company is outputting. Okay, so examples of that could include the rent of the building, the advertising, the insurance, the machinery, the office supplies. All of these items will not increase in cost with increasing output. Okay, variable costs, on the other hand, will increase for each unit of output. Okay, so it will depend on the quantity produced. And examples of that might be payments for material and labor. So you will hire more people and you will get more units of output. You will purchase more materials and you will get more units of output. And the total cost is made up of these 2 components, the fixed costs plus the variable costs. Short-run total costs. The short-run total costs curve is a graph that shows the relationship between the quantity or amount being output and the production costs. Okay, given that you have a fixed production facility, the short-run costs will equal to the fixed costs plus the variable costs. Okay? If we look at this on a graph, the fixed costs constitute a straight line, a straight horizontal line, because these costs remain constant no matter how many units of product are produced. So in this factory, they're producing paddles, and the rent of the facility will not change no matter how many paddles they produce. So they will have fixed costs that do not change no matter how many paddles are produced. In addition to these fixed costs, there are variable costs, and these variable costs will change depending on how many paddles are produced. Okay? The variable costs will not necessarily change in a fixed line. As we discussed in the previous slide, we might have differing improvements in output for each unit of input. Okay? And this will also mean that we will have differing costs for each unit of output. Okay? And what we can see in this particular graph is the costs per unit output start to increase a lot at the ends of the curve here. And this would naturally determine how many units that company might decide to produce. Okay? Now when we add these two components together, we get the total cost curve. So it's just the same shape as this variable cost, but shifted upwards by 100, which is the size of the fixed costs. A firm's average cost curves, so these are graphs, remember? A firm's average cost curves are developed by dividing each of the costs that we've previously described by the quantity or amount produced. So we're getting a cost per unit item produced. Okay? So that means that the average fixed costs will be formed by dividing the fixed costs by the quantity produced. And we can represent that with a formula. This stands for average fixed costs is equal to the fixed costs divided by the quantity produced. Okay, so we can represent that with a formula. Okay, similarly, the average variable costs will equal to the variable costs divided by the quantity produced. Okay, so this we can also represent as a formula. The average variable cost equals the variable cost divided by the quantity produced. And therefore the average total cost will be found by dividing the total cost by the quantity produced, but we can also represent that by adding up the average fixed cost and the average variable cost. So we have a number of formulas down here, and then this just describes the two ways you can calculate the average total cost. You could find the total cost and divide it by the quantity produced, or you could take the average fixed costs and add it to the average variable costs. And these are given by these two formulas here. The fixed costs divided by the quantity produced and the variable costs divided by the quantity produced. So you add those two together to get the average total costs. The marginal cost is defined as being the change in the total cost that you get for each additional unit. Okay, and this could change for each additional unit. So for example, if we have decreasing marginal costs, this value would go down for each additional unit. Whereas if we have increasing marginal costs, this value would go up for each additional unit. Okay, so if we want to express this idea as a formula, we can write marginal cost as MC, and this is the Greek letter delta, and it stands for the change in. So it's the change in total costs divided by the change in the quantity. Okay, and this is the same thing as saying it's the change in total costs per unit of additional output. Okay, when we increase the output by 1 unit. Okay, so in words, change in total costs divided by change in output. So here we can see an example of production of lemonade. Okay, so you can see each column represents a different one of the definitions of cost that we've previously discussed. Okay, and what you can notice about the fixed costs is that they do not change no matter how many glasses of lemonade are produced per hour. Okay, so this remains fixed. There's a fixed cost of $3. That means if you produce no lemonade at all, you still have a total cost of $3. Okay, that might be the investment in your equipment for making the lemonade, for example. Okay, now the variable cost, on the other hand, we can see that the variable cost goes up for each additional glass per hour of lemonade that is produced. And that will make sense to you, because if you're making more glasses of lemonade per hour, you will need more lemons, for example, and more bottled water perhaps, so your costs will go up. What is more interesting is if we look here at the average variable cost. Okay, the average variable cost, remember, is the cost per unit. Okay, it's the variable cost per unit. And in this example, the variable cost per unit is going up. Okay, so each additional glass of lemonade, it is increasing the average variable cost in this particular example. Okay, but remember, the average fixed cost is made of the total fixed cost divided by the numbers of glasses produced in that hour. Okay, so when you're only producing one glass of lemonade an hour, the total fixed cost will be attributed to that particular glass of lemonade. So your average fixed cost would be $3. But if you double your rate of production, the fixed cost averaged over the number of glasses produced will decrease. It will half. It will go down to 1.5. And that's because it is now the total costs divided by, it is the fixed costs divided by 2. Okay, and if we increase the rate of production to 3 glasses per hour, it would be the fixed costs divided by 3. So that would be reduced to 1. Okay, so combining this average fixed cost, which is decreasing for each additional unit per hour of output, with this average variable cost, which is increasing for each additional unit per hour, will give us the average total cost. And remember, that is just the total cost divided by the number of glasses per hour of lemonade produced. Okay, so the average total cost is initially decreasing. And that is because at the start, the fixed cost is forming a big part of the total cost, and that is reducing. But this reaches a minimum at 5 or 6 glasses per hour. Okay, and that is because the variable cost is increasing. So we can see that average total cost is decreasing until you reach this, which might be like an ideal rate to produce, and then it starts to increase again down here. Okay, and again, that's because the variable cost per unit, which we would call the average variable cost, is increasing in this particular example. It's not always going to be the case, but in this particular example, it's increasing. Okay, so we can also look at the marginal cost. And what we can see is that the marginal cost will increase at the start. And it will continue to increase by an amount equal to the additional cost for each additional unit produced. Okay, now we'll have an example of an exercise for you to complete. Okay, this particular exercise is the cost associated with producing shoes, and some of the values are given to you and some of the values remain for you to calculate. So please take out pen and paper and calculate all of the missing values from A through to Q. The solutions for this exercise are given for you here. If there's any difference between the answers and what you have obtained, please go back and try to calculate it again. Thank you very much.